Your brain processes a song in under a second, but reading this sentence takes 3 times longer. This isn't just about speed, it's about two completely different neural superhighways. Language dominates the left hemisphere of your brain, specifically in areas like Broca's and Wernicke's regions. This is where grammar, syntax, and meaning are meticulously decoded. Music, however, is a full-brain workout. It lights up your right hemisphere, engaging emotional centers like the amygdala and memory hubs like the hippocampus simultaneously. Scientists using fMRI scans have proven this. When you listen to speech, your brain activity is concentrated and localized. But play a melody, and it's like a neural fireworks display. Here's a shocking fact. Infants can distinguish between complex musical rhythms and tonalities long before they can understand their first word. This suggests our brain's fundamental wiring for music predates and is more deeply embedded than our capacity for complex language. Consider this clinical observation. Patients who have lost the ability to speak due to left hemisphere strokes can often still sing perfectly. This is because melody processing resides primarily in the right hemisphere, completely bypassing the damaged speech centers. Your brain also anticipates music differently. When you hear a song, your motor cortex activates, preparing your body to move before the rhythm even takes hold. Language doesn't trigger this same physical response. You don't feel compelled to dance when someone speaks, no matter how eloquently. The brain's reward system responds more intensely to musical anticipation than to linguistic prediction. That feeling when the chorus drops, that's your brain releasing a flood of dopamine, more powerful than the satisfaction of understanding a complex sentence. Memory encoding is another battleground. Music memories are stored as multisensory experiences, emotion, movement, and context all intertwined. Language memories are typically more semantic and factual, the what without necessarily the emotional how it felt. This explains why a song can transport you back decades instantly, while recalling written words requires conscious effort. Even your brain waves synchronize differently. Music induces theta and alpha wave patterns associated with relaxation and creativity. Language processing creates beta wave patterns linked to active concentration and analytical thinking. So next time you put on headphones, remember, you're not just listening to sound, you're conducting a symphony of neural activity that makes language look like child's play. Please subscribe for more.